We will now hear a presentation from KidSwitch. KidSwitch is a team of only female students at Stanford. And you can start sharing your screen now. And this is, to me, very interesting, super exciting, and I actually feel a little proud as well, because this team came out of a couple of different classes at Stanford, where ideas were born, and now the team is setting up a company to try to really take this to the next level. So I'm happy to introduce KidSwitch, and we actually have the whole team presenting, and I'll hand it over to you to introduce yourselves and your concept.
Thank you. So we are here today to learn about innovative ways to build better buildings, but what of those we have already built? 80% of the buildings that will exist in 2050 have already been built today. And yet that does not necessarily mean that they are suited to meet our changing needs. In California, 3.5 million new housing units are required by 2025 to meet an ever-growing demand. It's an extremely challenging number, and yet existing buildings hold a hidden potential. Currently, vacant commercial buildings in California have the capacity to hold 6 million housing units, or 2 times the projected increase in demand. So this led our team of graduate students here at Stanford to ask, how can we leverage industrialized construction methods to facilitate commercial adaptive reuse and turn underutilized floors into affordable housing?
So we began by designing a panelized kit of parts to fit within an existing structure. So we wanted to develop a product that could easily be brought on site and made to fit between the existing floor and ceilings. And that way we could create a fully functional housing unit. So by leveraging industrialized construction, we hope to streamline the adaptive reuse process and facilitate continuous improvement of our individual components. We found that the key component of converting commercial buildings is the kitchen bathroom wall system. So it's both complex and repeatable, and that makes it a great fit for offsite manufacturing. And we project that the prefabrication of this component would reduce construction time by up to 70% and cost by 20%.
In addition to the reduction in construction time and costs, we also anticipate a significant reduction in design time. By using a standardized kit of parts, we can create a spatial and energy-optimized housing layout with 3D modeling tools. The first challenge we had to solve for was adding multiple kitchen and bathrooms to a floor plan that usually has only one. We addressed this by placing the kitchen and bathroom close to the existing core, thus simplifying the mechanical and plumbing distribution network. Next, we wanted to simplify panel installation and future maintenance access. Each housing unit has one set of kitchen and bathroom wall panels located adjacent to the corridor. We are trying out different ways of sizing these panels to ensure that they can fit in any standard elevator shaft. Given the higher slab-to-slab height in commercial as well as office buildings, the MEP distribution runs in ceilings and over the corridor, which then connects to our integrated electrical and plumbing wall system. Hence, making it easier to pump hot and cold water from existing core and down to the respective floor and through the ceiling. Placing these kitchen and bathrooms close to the corridor would mean that we can easily leverage natural daylighting and ventilation for all the other parts of the housing unit, like the living and bedroom. Subsequently, we can reduce energy consumption as well as plug loads throughout each housing unit.
Okay, so now I'll take you through the process flow of one project. As you can imagine, performing industrialized construction within existing structures comes with a lot of complexities because of varying existing floor plans. So one of the main challenges of our concept is where to draw the boundary between what is done on-site and what is done off-site. Therefore, an important part of of our project is the information production system that's shown here on this slide in red. Of course, it starts on site. We are working with LiDAR scanning companies to take precise measurements in the building. Then an as-built model is created on Revit. And finally, our unit design and floor layout are customized using digital tools that are available in the Autodesk suite. And so to link it back to what my teammates were presenting, we, as they were saying, we standardized key components of our kit of parts in order to streamline this process. And what it allows us to do is that this standardized unit design comes and feeds into our information production system, which allows for a parallel process with permitting first, and also manufacturing. This saves a lot of time. And according to our preliminary product system model that we did in the previous month, we estimated that a final throughput of 10 units could be assembled in under a week.
Now, this approach lends itself to partnerships with cities, providing urban infill housing through reclaimed properties, reducing the impact of noise and dust pollution on neighboring communities through off-site manufacturing, and minimizing strong labor union resistance by providing compromise for labor unions between on-site work and off-site components. This approach is also sustainable. Adaptive reuse outperforms demolition and new construction, with even energy-efficient buildings taking up to 70 years to recoup the CO2 equivalent difference. Additionally, prefabrication methods have been found to be less carbon intensive and more cost-effective than traditional methods due to less labor and more efficient manufacturing processes. This helps especially with complicated components such as kitchen and the bathroom pods. By standardizing these components within a wall panel, sourcing sustainable materials, and making the panels disassemblable, a wall's lifespan is no longer limited by its weakest link, and instead, individual materials can be recycled or reused in a circular production model, which saves on costs, emissions, and waste.
So, as most of our team has taken Dr. Lessing's Industrialized Construction class, we made sure to evaluate our use case using the ICE framework, strategically positioning ourselves around the use of IC technology and market focus. And now that you have a better understanding of our concept, let me give you some insights into our trajectory. As I mentioned, our team came together during our graduate studies in sustainable design and construction. And now, after engaging dozens of stakeholders and benefiting from mentorship and support, we are moving into our prototyping phase, iterating designs and 3D printing test components. Going forward, we hope to further our key areas of focus and build a coalition of partners around a full-scale prototype and pilot. So to conclude, adaptive reuse not only offers an efficient way of providing much needed housing, it also extends the use phase of underutilized buildings, makes our existing building stock more livable and energy efficient, and does so through a thoughtful and sustainable process for communities built from old and new that can thrive together. Thank you very much for your time and attention. As always, feel free to reach out to any of us with our contact information below with any questions.